All right, we're going to take a look at properties of acids and bases. So if you missed the lab, I'm going to show you guys some pictures of what the data was for the lab that filled out this chart here. So for HCl, this is the reaction for phenolphthalein in the first one here. It's a kind of cloudy, clear. Then for the methyl orange, it's kind of like a dark reddish color. Bromediamyl blue turned yellow. And then the universal indicator was like a red, about a 4. For the first boxes for the litmus paper, the red litmus paper didn't change. The blue litmus paper turned red. And then the pH paper turned a deep red, which indicates a 1.0 pH. Then for the acetic acid, the second column, so we have the pH paper red stayed red, blue turned red-pink, and then the pH paper turned like a burnt orange color, it's about a 3. Phenolphthalein is the same, this is a clear here. Methyl orange is still like a burnt red, yellow for bromediamyl blue, and universal indicator is still in that red area. Then for our bases, so the red litmus paper turned blue, blue litmus paper stayed blue, and the pH paper for NaOH turned a deep blue color, indicating about an 11.0. Then our phenolphthalein turned a hot pink, like a deep hot pink. The methyl orange was like just a light orange, still kind of clear and see-through. Bromediamyl blue was a deep blue, and then it was like a deep purple for the universal indicator, which is about a 10.0. Then the last one, NH4OH, the phenolphthalein is a hot pink. Methyl orange, still that like lighter orange color. Bromediamyl blue is blue. And the universal indicator, it's kind of hard to see, but it's about a green orange, so about a 9.0. The red litmus paper turned blue. Blue litmus paper stayed blue. And then the pH paper was about a green color, so about a 9.0. So after filling that out, we observed baking soda and hydrochloric acid. When we mixed the two together, we observed bubbles in the flask. The little bubbles were CO2 gas escaping. So that's what we observed in the test tube. And then if you looked at the equation on the instructions here, you look at the products for the gas released. In the neutralization reaction, the acid by itself would be here the yellow, and it would have a red indication. So the bromediamyl blue turns yellow with the acid. When you add the base to it, it ends up turning blue. So in our boxes here, we have acid alone was like a red pH of 1. Bromediamyl blue, that one turned yellow. When we added the base, the pH went closer to neutral. So we dipped the pH paper in, and it was about a 6.0. Feeling bases, describe to yourself what like shampoo feels like, what soap feels like. If you were to touch Windex, describe the feel for part 4 here. For part 5, you guys will play the simulation. So you'll go to the instructions. On the instructions here, you'll scroll down to that part. So here we go, part 5, pH scale. So on the game, you will drag over the green. At the top, you're going to go through all of them. So start with battery acid. If it is below a 7, it's acidic. Above a 7 is basic. 7 itself is neutral. So you'll add a little bit, and you'll see the pH is a 1.0. So you'll go and you'll record that in your chart here. And do the same with all the other substances. Then it says what happens to the pH of the acid when water is added. So in a sentence, when water is added, the pH of the acid will do what? Increase or decrease. Then you're going to add water to a base and see what happens to the pH. For the river water test, we go back to our pictures here. Here's the river water test. So when we dipped in the red litmus paper, it stayed red. The blue turned red color. The pH paper was between a 3 and a 5, so the river water itself, testing throughout the day, came out with more of a pH of a 3. This one, even though this one's between the two. So 3 to 4 Phenolphthalein had no reaction, so it's clear. Methyl orange was like a dark red. Bromthiamyl blue turned yellow, and universal indicator was about a 4.0 and turned red color. So that's what we would record here. So what do we know about the nature of the river water, and support your answer with evidence? So compare your river water to your chart up above here. Is it closer to the properties of an acid or closer to the properties of a base? And describe what you see. Say, okay, universal indicator was this color, it matched here. Bromthiamyl blue was this color, it matched here. What matched from this chart to your first one? Then you're going to go ahead and watch these two videos here. And they show you how the pH of water is detected for acid mine drainage, what it does to the river in these two videos here. After you're done watching that, it says we listed ammonia as one of the possible pollutants of the river water when we began our investigation. So review the information for ammonia. So you'll click on it and look for ammonia. And then it says, could ammonia have contributed to the fish kill? Think about what our river water's pH was and the properties, and then go back up to the first chart where we have ammonia hydroxide and compare it. Based on these, is it similar or different? If it's similar, it could be present. If it is not similar, I would not expect it to be present. So go ahead and answer that for number 2. Then you'll move on to Arrhenius acids and bases. Read through the paragraph here, and you'll highlight where the acids and bases are. Acids are indicated by an H+ ion or the hydronium H3O+ ion. Bases, on the other hand, are OH-. So if it has more OH-, it is a base. More H+ or H3O+, then it's an acid. Think about what happens when you combine H+ and OH together. Those 3 atoms, what do they make? What molecule do those 3 make? And look up here for some hints as to what it might make as the product. Then we're going to look at our scale here. If it has a number below 7, more acidic, it's going to have a higher amount of H3O+ and a lower amount of OH-. But if it's a number that's greater than 7, it's going to have more or higher amount of OH- and a lower amount of H3O+. So you're going to look at these and look at the numbers. So if you have like 2.5, if you scroll up to 2.5 here, it has more or a higher number of H3O+, which would mean it would have a lower amount of OH-. So you put high and then low in the boxes, and you'll continue that for the other boxes. Last question is, what does the pH of the river water tell you about the concentration of different ions? So here's our river water. Based on how the chart looks above, does it have more H3O+ or more OH- if our river water is acidic at a 3? So use that chart to help you answer number 5. And that is day 9, acids and bases.